Hi, so I wanted to go through all of the rules for the Desmos Polar Bear project, step by step, so that you have no misunderstandings. This is something that we didn't really have time to do today. I just gave you a general outline, but there's some things that I want to make sure you know, and I have to make one or two corrections because I realize that that's not some of the things I said. I want to make sure that we're at an honors level for this. So what we're doing here, I'm reading this document right here, is we're creating this polar bear project. And you've already done this stuff right here. You've already done these, right? And so now we're here creating your Desmos. So here's a very, very important thing. When you create your Desmos design, you have to log into Desmos. What do you have to do? Log into Desmos. How do you do that? You log in by logging in with your Google Classroom. So I can't stress this enough because you want to save all the work that you've done, that when you start creating it, you need to log into Desmos in order to do that. Okay? So how do you log into Desmos? Well, I'm in Desmos here. I'm going to save this and call it Hawk. Right? And I could move this out of here. But it's important that when you get a new Desmos here, right, that you come in, that you see your name here, right? So say I logged out and I need to log back in. I'm going to log in using Google Classroom. There I am. And I'm in now. You should see your name here. So I've said it like 5 times. Log into Desmos so you can save it. You're going to insert your image into the graph. We've talked about that. You can either do a Shift Command Control 4, or you can do Shift Command 4. Either way, you're going to be able to find your image. You can either drop it right on there, or you can uh, open it up in your desktop and drop it from your desktop. So you're going to insert the image. You're going to increase the transparency so that it is very light. So maybe a 0.5. It's at a 1 right now, so you'll put it down to like a 0.5. And then you're going to use that light image as a template and create lines over that original there. Next thing, you're going to save your work as you go along. So I cannot stress that enough, that you save your work as you go along. So I open up my graphing calculator. I go here to that. I'm going to pick my Hawk, right? Now, what did you guys do? Let's go back for a second. Um, we're gonna, we want to create. So we hit our plus. We've already done our Shift Command 4. We look at image, and there it is for me. So I can drop it in there. So I'm starting over here, right? You got a bear. Now I go to opacity. I'm going to make that much less, 0.5. And you can see that. I can go to 0.4 if it wants, or 0.3. I'm making it so that I can see it, but it's not getting in the way. Now, look at your width and height. You do not change these. You do not want to drag and make it either stretch vertically or horizontally. You do not want to do that. What you want to do, just like when you're putting pictures in a doc, is you only want to click on these corners and drag out. Either the length or the height has to be at the 1010. So right now, I am going to pull out to 1010. Do I keep going? Yeah, look at my hawk. It's not even close to 1010. So now I'm getting up. That looks pretty good. If it's a tiny bit off, I'm okay with that. But right now, this is looking good. I might go a little bit more. There you go. So don't go bigger than 10. Try to get either the height. Uh, let's see. I'm bigger than 10 on the wings. I'm not talking about the purple box. I'm talking about the wings, right? So I may go down just a tiny bit so that is in 1010. So that's great. We're going to call that 1010, right? Now look at this blue box up here. See how it says save? You should save it. Um, So there's a way of entitling our graphs. So let's take a moment now to talk about that. So we're going to save our work as we go along, like 5 times, 10 times an hour, right? When you work on this project complete and you're going to delete or fade out to zero the opacity of that original design, right? So here's what we need for all of this. The project is entitled. So here's our title, last name, Polar Bear, linear function project. So that is a really good way of labeling it, right? That's the project title. It should have a minimum of 30 equations, right? A minimum of 30 equations. When we do our rubric on this, I'm going to write down the number of equations that you have. You're going to also report it, and I'm going to check. If it doesn't have 30, ooh, very, very bad. You must include, and you may not reuse any line to satisfy another category. So, in other words, here we have one vertical line, right? One horizontal line, one positive slope greater than one, a positive slope that is less than one. So, what's a positive slope that's less than one? Think about it for a second. What's a positive slope less than one? Yeah, it's a slope that's a rational number, like 2/3 or something like that, right? That's positive, but less than one. One negative slope greater than one. So that it's going to be a more negative than one, right? And one negative slope that is less than one. So it'll be less negative than one, but still negative, like negative 2/3. One set of perpendicular lines, right? Well, can my perpendicular lines also include my vertical and horizontal? No, we may not reuse these. So you need another set of perpendicular lines, one set of parallel lines. Hey, can my parallel lines include a vertical or a horizontal? No, you may not reuse. Get the idea? Here's a biggie because we're going to be turning these into physical, in real life objects. The polar bear outline has to be a closed polygon, which means that I'm not talking about like the interior, like if you put in an eye or a nose or something like that, but the exterior outline has to be a closed polygon. Okay. All line segments must meet at a vertex, which means that when I have two line segments meeting, um, they must have the same set of ordered pairs for that vertex. Get it? So it's not just like, oh, they kind of look like they meet, but we're looking at the ordered pairs of those two equations of the lines with the limits, and they have the same X values for the limits. Got that? Must have line segments in all four quadrants. I think that's going to be automatic just because you're doing it around the origin and it goes from -10 to +10, both X and Y. You may not use sliders. So this is a huge one. So in class, I showed that you could use sliders. And that means that you're not really thinking. You're just sliding away. Hey, good job using the slider. You already know how to use the slider, so I am saying that you may not use the slider. Now, when you submit your doc to me, when you submit your project to me, it is a live um, product. So I will be able to go in and see what you've done. So please do not use sliders for anything. It's very tempting. Instead, what we're going to do, I'll I'll show you how to do it in a second. Instead, we're going to be just putting in a equation of a line that you think is close to the slope and close to the intercept, and then you'll tweak it. So what I did in class, it was that process after using sliders that is the most important. So let's get rid of the sliders altogether, and we're just using that. Instead of having a limit of 0.5, maybe you'll have 0.55. Instead of having a slope of 0.7, you might have it 0.71. You get the idea. Okay. Another one is graph is an accurate representation of the original approved design. So now let's go back to my graph. So what am I saving this graph as? I had it written down here. Where is it? Boardman, right? Polar bear. And then linear function project. Okay, now I got my perfect one here, right? Let me open this up a little bit and show you what I'm talking about. So I want to do this. Yeah, I can hide that now. No, I can't. Okay, so I'm sure I can move that down lower. How about that? So now I'm going to start. I'm looking at this line right here, this line segment. So I see that the intercept is at 1, 2, 3. Let's say, oh, this is 2, 4, 6, 7.5. Let's do that. And I think my slope is maybe down 1 over 1. Let's just put that in as y equals -1 x. And then I said it was like 7.5 plus 7.5. So I am pretty close with that on all counts. Now I start zooming. So when I look at the zoom, I say, well, that 7.5 wasn't great. I'm going to go down and try to make it 7.3 better, 7.2 even better, right? If I want to make it a little higher, 7.25, now I'm doing well. Let's talk about the slope. This slope, if you look at it, it is too negative. That slope is too steep. So you can do a little trial and error with this, but I know it's too steep. It's too negative. So I'm going to put in a negative 0.9 and see if that works, and 0.8. Law, that looks beautiful. Now, are we done? Absolutely not, because if you look at it, that is a line, not a line segment. So what I want to do now is create my limits for this. So I'm going to drop this out for a second and look at where these points are and give a guess at it. And then I'm going to put it back in there and say, that's probably where I'm at. This will only work when I have a line showing that I can get the coordinates. But if you need, you can drop it out, drop it back in to get an idea of where it is. So I'm going to say that my, and I'm only looking at the X values, the X inputs for my limits. I'm going to say that's a negative 3.2. I use my braces here. I put in my X. I put in that this X is going to be, let's make sure that we put in the X is greater than or equal to, and it was a negative 3.2. Is that right? Oh, that's beautiful. Let me zoom into that. I love it. So now I'm going to the other limit here. So I might have to shut it out, take it off, put it up, take it off, put it up. All right. This time I'm going to do it like this because I know I want to tweak it. I'm going to say it's 3.9 for X. So again, using this less than or equal to, and I'm going to put 3.9. All right, let's see how close we came. I'm thinking I'm going to stretch this a tiny bit more, 3.95, and that looks good. How's that look? So far, I got one done. Everything's going great. Now, I want to continue on building up this. And I can see that one of my limits here was here. What did I say it was? 3.95. So I'm actually going to copy this set, bring it down here. And I'm going to make this line here. And I know that one of my limits is that 3.95. So let's take a look. This to me looks very much like a horizontal line that goes to here. So I am going to make a horizontal line at, I think, AU. X equals 4, I think. No, Y equals 4. Y equals 4. So now I get this green, and you can see I've already had this here. That looks a little too low, so I'm going to do 4.1. No, 4. Yeah, 4.1. And now you can see that I'm getting super close here, right? So this blue line here, let me get rid of this for a second. This blue line ends at what? At 3.95 there. So I'm trying to get my other line to end at that same point as well. You get the idea? When I put this back on, it looks like these are a little off, right? 3.9357 or whatever. So I want to drop this down a little bit. That's too much. And those points will have to be the same for both of them, right? We cannot have any line segments that don't share those points on there. Got the idea? All right. I think you folks are on your way here with this, right? So we see how this is my y equals 4.09. I just want to give it one more thought here. This should also be 4.09. See what I'm talking about? So the endpoint of this, I think I'm at the endpoint there, is 4.09. And then if I get rid of that and put on my green, the endpoint of that is a height of 4.09. You get it? Okay. So what can you do to save yourself a little bit of work? Well, if I wanted to do a parallel line of this, some two lines that are going to be parallel, I could actually copy the equations and just change the intercepts on that. Sound good? Um, so we have some deadlines here. So I have my deadline here for October 7th is our first deadline here. So October 7th is going to be our first deadline where you are going to be submitting this to us. And oh, I forgot to save this. Boy, how about if I stop? Now it's all saved, ready to go. So October 7th is our first check-in. You should be about 50% done, if not more, on that October 7th. That's super important. So I'm going to stop my video now, and that's our guide for now, looking at October 7th. Okay? Good luck.